Hello students, welcome back to my channel. In this video, I will discuss one of the important category of organic photochemistry, the photocycloaddition reaction. One of the important reaction in photocycloaddition is the Paterno-Buchi reaction. Paterno-Buchi reaction. By using Paterno-Buchi reaction, we can prepare Oxetane, the photo-induced addition of aldehydes or ketones to olefin to give Oxetane is called Paterno-Buchi reaction. That is, the photo-induced addition of aldehyde or ketone to an olefin to give, whereby giving Oxetane, is usually referred to as Paterno-Buchi reaction. It is a typical Paterno-Buchi reaction whereby this Oxetane is formed. See, it is a ketone, benzophenone, which on treating with this alkene, propene, photocycloaddition reaction takes place, or Paterno-Buchi reaction takes place to form this Oxetane. Okay, usually Paterno-Buchi reaction leads to the formation of two isomeric oxetanes. Among the isomeric oxetanes, one is obtained as the major product, while the other obtained as minor product. And so two oxetanes are produced. It can be explained on the basis of its mechanism. The Oxetane formation takes place in two stages. In the first stage, the carbonyl compound gets excited, and the excited carbonyl compound first adds through its oxygen atom to the alkene so as to give mainly a more stable of the two possible diradicals. Two diradicals are formed isomeric in order to form the isomeric oxetanes, and one of the diradical is more stable than the other. Okay, then in the next stage, a spin inversion occurs and the second bond is formed in order to have the cyclic Oxetane. Okay, the mechanism consists of addition of an excited state of carbonyl to the ground state of the olefin. First of all, this carbonyl compound singlet excited to its triplet, and then the triplet, or maybe in some cases the singlet itself, may combine with olefin in the ground state to form two types of diradicals, either this diradicals and or this diradical. Either of the diradicals are formed. Among these, it is more stable because of the benzyl radical and this tertiary carbon atom. This diradical involves benzyl radical and a tertiary carbon free radical. But this diradical consists of a benzyl radical and a primary carbon radical, and hence it is less stable diradical compared to this diradical. Okay, then Oxetane ring is formed by spin inversion and bond formation between these two carbon atoms. Spin inversion and bond formation between these two carbon atoms, either of this, in this case these two carbon atoms, and in this case these two carbon atoms. Ring closure takes place to form two isomeric oxetanes. Among this Oxetane is obtained as the major product because it is formed from a more stable diradical. That is, this diradical is actually consists of a tertiary carbon free radical and a benzyl free radical, and hence it is more stable compared to this diradical. Here a primary carbon atom consists of one odd electron, and hence it is a primary carbon free radical, and it is a benzyl free radical, and hence it is more stable than this diradical. After the formation of diradical, spin inversion and bond formation between the carbon atom takes place to form these two oxetanes. See these examples. It is an alpha beta unsaturated cyclic ketone, which on treating with this olefin or alkene, we will get this Oxetane. The same mechanism follows for the formation of Oxetane through the biradical. Then here 2 plus 2 pericyclic cycloaddition may also takes place between this olefinic component and this olefinic component. Thereby, a bicyclic compound may be produced as the minor product. Then see this example. It is acetone, which on treating with this olefin. Paterno-Buchi reaction or Oxetane formation takes place, forming this product, Oxetane. See this reaction. The ketone reacts with a diene, a conjugated diene. Photocycloaddition takes place as in the previous case, forming this Oxetane. But this Oxetane is somewhat unstable. Ring opening takes place with the elimination of a formaldehyde molecule, CH2O, forming this compound. Okay, that is this ketone, benzophenone, reacts with the conjugated diene. Photocycloaddition first takes place to form Paterno-Buchi reaction takes place to form Oxetane. Here Oxetane is first formed, but it decomposes with the elimination of formaldehyde, forming this stable product. Okay, the Paterno-Buchi reaction is not stereospecific because the time lag before the final spin inversion is more than enough for rotation to occur about single bond. That means bond rotation is faster than spin inversion. For example, cis and trans 2-butene give the same mixture of cis and trans oxetane with benzophenone. One of the important conditions for the formation of oxetane or Paterno-Buchi reaction to take place is the triplet energy of the triplet of carbonyl compound should be less than that of alkene. Otherwise, triplet energy from carbonyl compound to alkene takes place to form dimer of alkene. Dimerization, otherwise dimerization takes place. That is, the triplet energy of the triplet of carbonyl compound should be always less than that of alkene. Otherwise, energy transfer from triplet of carbonyl compound to the alkene molecule takes place, whereby the alkene gets excited and hence it dimerizes together with another molecule of alkene, forming a dimer of alkene instead of getting oxetane. For example, you can see here it is benzophenone, which on irradiation, first it gets converted into excited singlet, then through intersystem crossing, it gets converted into its triplet with the triplet energy 70 kilocalories per mole. But the triplet energy of norbornene is 72 kilocalories per mole. That is greater than that of benzophenone. And hence no energy transfer takes place to norbornene, and hence triplet of benzophenone reacts with alkene, forming oxetane. Otherwise, if for example, if we take acetone instead of benzophenone, if we take acetone, which on irradiation, first of all, its singlet is formed through intersystem crossing, its triplet is formed, that is acetone triplet, which having triplet energy 78 kilocalories per mole, but norbornene triplet energy is 72 kilocalories per mole, that is less than the triplet energy of acetone, and hence energy transfer from acetone triplet to norbornene takes place, whereby acetone gets relaxed to ground state while the norbornene gets excited to its triplet, and this norbornene reacts with another norbornene triplet, or dimerization takes place to form dimer of norbornene. Here we will not get oxetane because the triplet energy of carbonyl compound, here acetone, is greater than norbornene, alkene, and hence triplet energy transfer takes place from carbonyl compound to alkene takes place in this case. Thereby, dimerization of alkene takes place, forming the dimer of norbornene instead of getting oxetane. Okay. In most cases, quinone react normally with alkene, giving oxetane product. But other alpha beta unsaturated ketones usually give preferential cyclobutene formation, which is a pericyclic 2+2 cycloaddition reaction. Here it is alpha beta unsaturated ketone, but it is quinone. Alpha beta, even though it is alpha beta unsaturated ketone, it is quinone. Quinone usually gives oxetane by reacting with the alkene, but other alpha beta unsaturated ketone gives 2+2 cycloaddition reaction, pericyclic cycloaddition reaction, forming cyclic product, adduct, cyclic adduct. These are some of the example involving heterocyclic compounds in Paterno-Buchi reaction. In the first case, benzophenone reacts with the 2,3-dihydro-1,4-dioxane. It is 1,4-dioxane, 2,3-dihydro-1,4-dioxane. Photocycloaddition reaction or Paterno-Buchi reaction takes place to form, first of all, this diradical, and this diradical cyclization takes place, and hence a bond between these two carbon atoms, forming the product Oxetane. This Oxetane is produced by reacting these two reactants. Okay. Then if we take the second example, it is the aldehyde of furan, a heterocyclic compound, which reacts with an alkene. Paterno-Buchi type reaction takes place, forming this Oxetane. Another important reaction involving heterocyclic compound in Paterno-Buchi reaction is this. Here, benzophenone reacts with this heterocyclic compound. Photocycloaddition reaction takes place, or Paterno-Buchi reaction takes place to form these two diradicals. These are the possibility of diradicals formed from this reaction. Among these, this diradical is more stable than this, and hence the Oxetane formed having this structure. It is the Oxetane formed from this diradical, and it rearranges by ring opening. See here, this hydrogen shifts from this position to oxygen, and bond or ring opening takes place, forming this product by the rearrangement of the formed Oxetane like this. The ultimate product of this reaction is this product. Okay. Then Paterno-Buchi reaction of ketones with dicyanoolefin is stereospecific with retention of configuration on olefin component. If the olefin component is cis, the product of Paterno-Buchi reaction is with cis configuration with respect to olefin component. See, it is cis dicyanoolefin, and hence we get an Oxetane having cis configuration with respect to olefinic component. If you take a trans dicyanoalkene, we will get trans product with respect to olefinic component in the Oxetane. Okay. Intramolecular Paterno-Buchi reaction may also take place in some cases, provided the functional groups are suitably oriented with the same molecule. See here, the functional group alkene and this carbonyl group are oriented in such a way to form this Oxetane, and hence in this case intramolecular Paterno-Buchi reaction takes place. See, it is the Oxetane by combining this oxygen and carbon, and this carbon to, and this carbon and this carbon, forming cyclic Oxetane product. You know the mechanism of this reaction. It is the diradical formed from this compound. Intramolecular Paterno-Buchi reaction takes place, forming this diradical, and ring closure takes place, forming the Oxetane. Similarly, in these molecules also, intramolecular Paterno-Buchi reaction takes place, forming this product. It is the Oxetane. This Oxetane on reduction with the lithium aluminum hydride, forming this alcohol. Right? Another example of intramolecular Paterno-Buchi reaction is this reaction. This ketone, unsaturated ketone, on irradiation, we will get this Oxetane and this epoxide. Okay, the mechanism of this reaction, intramolecular Paterno-Buchi reaction, is like this. On irradiation, two diradicals are formed, either this diradical or this diradical, and this diradical, from this diradical, a ring closure takes place to form this Oxetane, and from this diradical, ring closure takes place, forming this epoxide. Okay, I have already discussed all the aspect of Paterno-Buchi reaction and its mechanism with several examples. With this discussion, I hereby conclude my video. Thank you for watching. Thank you.